So this has been done through a beautiful idea called Dedicated cuts. What do you do? What exactly you want? You want to capture a point which is not. You know that square root of 2 is nice and good. How to capture this? This is the whole idea. Okay? So we will capture every point on this. How do you do that? Okay? So we introduce it, which is called a derivative. What does a cut do? See, you have the Q plus in your connection, and you are cutting it. How do you cut that? It partitions this into two sets. One below the cut that you have introduced, and one above this cut that you have introduced. But you just don't know how to describe this. So what you do is the following. Define a cut. See how mathematicians do various things. It's very nice to, if you understand it, it's very interesting. So what you define as a cut is a cut is a so it's a subset of it is a subset of Q plus. What kind of subset? We are not describing it. Okay. What are the properties? With the following properties. Suppose I denote it by, so I designate it by so psi is a cut. So psi is a subset of that's what you have in. What kind of subset? First of all, the first property is psi is that means it contains at least one element of Q plus. And psi is not the whole of Q plus. This is the one property. It doesn't sit completely. So there are so many sets with this property. So we have to be very selective, and we are aiming at a particular set which will enable you to continue to do parts. Okay? So what more is there? Every rational number, so if you take any x, is less than every rational number not in psi. That is psi complement. What you call psi complement. So what it says, every rational number in psi is less than every rational number not in psi. Okay. So if you take an x here, you take a y here, then x is less than y. Okay. You cannot say that. Suppose your y is here. It is, you cannot say that x is less than x may be less than y, but that may not be. So this is not true. What you insist on is that any element you take in psi, the complement of that it should be. So that of course says, see, this kind of sets cannot be. Suppose this is your psi. Okay. So what does it say? Take an x here, take a y here, x should be less than y, that is not valid. Therefore, you cannot have elements less than elements in this. So that the implications are very clear. Okay. One more property is that it does not contain okay. So what it has is a cut like this. So this connection is what you call psi, and this is your psi complement. And you see that I am only talking about rationals and not other points. So you see that it does not contain a largest rational. Okay. What does it mean? It means that given an element psi here, you can find an eta that is given x here belonging to psi, where x is y belonging to psi, y belonging to psi, y belonging to q, such that q plus that's the meaning of that. So there is no largest rational number that you can find. Such a set is what you call a cut. Okay? So psi is called out. So, in the nutshell, this is what it is. Psi is non-empty. Psi is not equal to the whole of q plus psi union psi complement equal to, of course, q plus. This is what you have. Then what you have is x belonging to psi, y belonging to psi complement implies x is y. That's the property. Then what it says is that given x belonging to psi, where x is y belonging to q plus, such that x is less than. These are the three conditions that you have. Such a set is what we call a cut. So if you think about it, it clearly, breaks it. Or sometimes it may be even like this. So Q and that is psi. Okay, now let us work on this. So you take all possible cuts off. So you take all possible cuts off. This collection is what you call. This collection is what you call this. Okay. Now for this collection we write the following. Suppose psi and eta are two such cuts. How do you define psi plus eta? Psi plus eta is defined this way. Psi plus eta is defined as the set of all x plus y such that x belongs to psi, y belongs to. But this means the following. Eta is from here to this side. Now what you do is you take an x here, you take a y here, calculate x plus y and then find out what it is. For instance, you take a simple case, you take x equal to 1, y equal to 2. Okay, then what does it mean? What is x plus eta or psi plus eta? Psi plus eta would be all x plus y such that x is less than 1, y is less than 2. Therefore, you take x plus y, you see that x plus y is less than 3. Okay, and then show that that gives a cut. Right? So that means all these conditions are satisfied by psi plus eta. So one has to prove that. Psi plus eta satisfies all the qualifications of psi plus eta means all of. So psi plus eta is a cut. Similarly, you define this collection. Now then show that psi eta is also okay. You define the set psi is contained in and not equal to the whole of P. So equal to means psi equal to means the set psi is equal to P. So I am using the same notation for the number. That means psi is contained in eta and eta is contained in. So that defines everything, like order, addition, multiplication, and order. And this is an extension of the addition and multiplication and order addition. That now you see, how sure are you that you get some new objects? For instance, you look at this one. Define psi as a set of all x for which less than 2. Now, is this a cut? That's the problem. It's when you have to verify each one of these properties. That this collection is non-empty. This is not the whole of Q plus. Then if x belongs to psi, then y belongs to psi complement. Then x is less than y. Then this given x belonging to psi and y belonging to Q plus such that there exists y belonging to Q plus such that x is less than, this is y belonging to psi such that x is less than. Sorry, I think that is a mistake. Please correct. Okay. There exists y belonging to psi such that x is less than y. So there is always y belonging to Q plus. There is no dispute about it. But what it says is that, see on the line, if you take psi, choose any x here, then there is some y inside psi. Now this set is called psi, such that x is less than y. That means there is no what you call a largest rational number in it. That's the meaning of that. So you see that this particular set qualifies to be this one, but this is not. You see that it's easy to get all these rational numbers because you take a rational number p. So let p be a rational number that is p belonging to x. Now I define psi as the set of all x such that x is less than p. So you see that you can easily show that this satisfies all the conditions of a cut. This particular cut is identified with P. So P induces a cut on the half length, and that is designated by. Okay, so psi is equal to. So every rational number is a cut. Therefore, now you can talk about cuts. So you consider all cuts. So every rational number is a cut. But what you gain is that there are cuts which are not rational numbers. Not rational. Like set of all x belonging to q plus such that x squared is less than 2. Two things have to be proved. First of all, this set is a cut, and then show that this does not correspond to, there does not correspond to any particular p for which this cannot be written as x less than 2. Okay, therefore this is not a rational number. So there are some additional things that come, and then of course on the new class of objects that you have created, you can define addition, multiplication as here, and the order relation can be there, and then one can verify that all the properties of rationals can be extended to collection of all what do I mean by that? You can show addition is associative, addition is commutative, that you can show. Then what more we can do? You have the interactive properties with the order. You have the interactive properties with the multiplication, especially the distribution property is there. Now with respect to multiplication, you can show that the new collection of cuts form a multiplicative group. So what you have is, so let me just make a definition. The set of all sides then R plus with addition, multiplication and order set. This is a multiplicative group. Which is commutative. Also commutative. There are plenty of elements which are not there in Q plus. So you have actually Q plus is this is what you get. And in fact, this is a proper containment of objects like square root of 2, square root of 3, pi, e, all these things are not in that class. But they are all there in R plus. This is the result that follows. So it means none of us. That's the structure. So what extra thing that you get? So you see that if you have psi and eta, eta belongs to R plus, then psi into mu equal to eta has a solution. And of course, if you check this equation, eta, then if eta is greater than psi, then your X is free in solution. So these are the two things that you can immediately get.